Okay, 5-1 is actually algebra, geometry combined. It's actually things about inequality. So when we're talking about inequalities, this works for angles, it works for side lengths. It also works for numbers that you use in algebra. So these things always work for both algebra and geometry. Okay, so a review. What is an inequality? Who would like to describe to me what an inequality is?
Like 7 is greater than 5.
Okay, greater than is an inequality because they're not the same. So we have greater than
Less than.
and less than. And how I remember it, again, you have to kind of remember, I look as the point, it points to the smaller. So the smaller thing here, the smaller angle, points to the smaller, so this one's greater than. This points to smaller, so this is less than. You also can have the equal to, but these inequality properties here are not including the equals. Okay, so the properties we're talking about right now do not apply. So these properties apply only to less than and greater than, not less than or equal or greater than or equal. Okay, because it usually will work, but sometimes it doesn't. So that's why we're talking about it. Okay, so the first one is if you have it's pretty stupid, but anyway, okay. Don't worry about it. Is if you have A and B, okay, or so yeah. So if you have two things, A and B, okay, either A equals B, A is less than B, or A is greater than B. That seems kind of like common sense, right? There's only three possibilities. If you have two things, A and B, then either those two things are equal, one of them is less than the other, or that one is bigger than the other. Okay? So that's really what the first one tells us. It's kind of a silly one because that's an obvious statement. Okay? So the next one is if you have A that's greater than B and you have B that's greater than C, then let's see though. A is greater than C. Because if this is bigger than B and B is also bigger than C, then A is greater than C. Okay, and so that's just telling us basically if you have a number in between them, then they are still A is greater than C. Okay, this really says, if you look at this, this really gives us that A is greater than B, which is, oops, go the other way, greater than B, greater than C. It works the other way too. If you have A is less than B and B is less than C, then A is less than C. Again, it's A is less than B, which is less than C. So this would be my smallest. This would be my largest. This is in between. We talked about in betweenness before. Okay, this would be my greatest here in this thing. This is my smallest. And this is in between. So those are kind of obvious ones, okay? It's just realizing that, but we can, if we have a line segment like this, and we have A, B, and C on here, A, B, and C, then you know this one, if this number here is -3 and this is 2 and this is 25, -3 is less than B. B is less than C, so A has to be less than C. That's kind of how it looks, okay? Same thing with lengths of sides. You can know if you know the length between them is greater, then you can say, it's in between, and so we can say one segment is longer than the whole thing, or less than the whole thing. Okay. The next thing is both the addition, subtraction property. I'm just gonna kind of take it and show you that if you have a statement where A is greater than B, this also works for less than, okay? Then A plus C is greater than B plus C, or A minus C is greater than B minus C. So if I take the same number and add it, or if I take the same number and subtract it, it's going to give me that true statement. Okay, if A is greater than B, then these continue, because if I take the same number away from A and B, there's still, that number is going to be bigger than the one on the other side, because I'm either adding the same number or subtracting the same number, but they're still bigger. Okay, so that's basically that one. What? That is not true. Oh, C is greater than 0. Okay, yes. I thought, what? That doesn't make sense. Okay, if A is greater than B, then, and C is greater than 0. This means it's a positive number. That's what it says. Okay, this only works, let's put those away for right now because we're not paying attention, and you need to pay attention. Thank you. You can look at them afterwards. I'll let you take them after class. So, if A is greater than B, and C has to be a positive number, then this is true. A times C is greater than B times C, okay? That is true. That's only when C is greater than 0, okay? If you do the other one, I'm going to tell you this one just to go along with it, okay? The fifth one goes along with this one. Actually, we won't call it the fifth one. If A is greater than B and C is less than 0, then AC is less than BC. This is when C is negative. Remember how when we solved inequalities, we switched that sign when we multiplied or divided by a negative number? Okay, that is still true. If it's negative, it's still true. It's kind of the opposite of this, because here we stated they were positive numbers and they stayed greater than. But if it's a negative number, then they become less than. And so that's an important one to remember. This is kind of our key one that we have to remember when we're solving inequalities. We have to remember that, because otherwise we will get the incorrect answer there. Okay, so I'm going to go ahead and erase some of these now. We just have a couple more. It's just going to go into, it did addition, subtraction, multiplication, and now we're doing division. So number 6, is that where I'm at? 6 or 5? 5, thank you. Have to number correctly. I was thinking 5 and I said, okay, So it's basically, division's the same way, okay? If A is greater than B, and C is greater than 0. Again, this makes a positive number. Then A over C is greater than B over C. Because if A is greater to begin with, and you put the same denominator under both of them, B is still, or A is still going to be greater, okay? But it gives us that other one that goes with this, which I'm going to kind of summarize. These are our two important ones. A is greater than B, C is less than 0, then A divided by C is less than B divided by C. So this is when it's negative, or A times C is less than B times C. So the key one that we always remember when we're solving inequalities are these two properties. They come from that property that if you multiply them by positives, they'll stay the same, okay? And so the key ones that we actually remember is if we're multiplying or dividing by a negative, we want to switch the sign. That's what we're actually doing there, okay? These are kind of interesting. So if A is greater than B and C is greater than D, okay, so these are our givens. If A is greater than B and C is greater than D, then, so first we have to have these two conditions. Let's do an example. 1 is greater than 0, okay? C is, let's make it 2 is greater than 5, okay? Then it says A plus C is greater than B plus D. A plus C is greater than B plus D, okay? Which makes sense. I'm taking the two that are greater than the others and I'm adding to the two smaller ones, so they should be, the inequality should remain. So that would mean that A1 plus 2 is greater than 0 plus 5. You guys didn't even check this. That's not a true statement. 2 is greater than 5. You guys didn't even say something? That like nobody had a brain go boing, 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 boing. That didn't make sense. If I write it, it doesn't mean it's right. Sometimes I make mistakes. You guys gotta check me. Okay? So now we're taking 0 plus 1 plus 5. So the two larger numbers added together is greater than the two smaller numbers added together, so I get 6 is greater than 2. That just shows you what is going on there, okay? So it's just saying, if you want to put this in words, if two larger numbers are added, then they are greater than the two smaller numbers added. Okay, that's really what that's saying. It's a lot of gobbledygook with letters, but just have to sit down and look at what it really says. It says, okay, if a number is greater than B and a number is greater than D, if I take the two bigger ones and add them together, then I take the two smaller ones and add them together, that will still be greater than. Okay, so that's what that property is really showing us. Okay. The whole greater than part theorem. So if we know that both of them are positive and they equal C, oh, yeah, okay. This one is just like this. So if you know that A is greater than 0 and B is greater than 0, this means that they are positive numbers or positive, that's what that means. If they're greater than 0, then they're both positive. So if A and B are positive, both positive, then and I say that I have A plus B is equal to C. So in other words, if I add those two together, they equal C. Okay. So we're given those two things, then the C is going to be greater than A, because if you take A plus B and add them together to get C, C is going to be greater than A and C is going to be greater than B, because these two make C. They're both positive, so that's going to be positive. Okay. It only works if they're positive numbers. Then C is going to be greater than the part A, and C is going to be greater than the part B. That's why it's called the whole parts theorem. But it's just really saying if you have two things added together and equaling C, each of the parts must be less than that whole number altogether. Less than flipped is C is going to be, the whole number is going to be greater than the individual parts of the statement. Okay. Now that's a whole bunch of garbly good, but it's just, it is the properties that people use. And so these are things we can use. Do we have to state the name of the property? No. But we have to say, okay, well, obviously I can divide by a positive number and it still keeps them the same. I can add the same number and it still keeps them the same. I can take this and say, oh, okay, we can add that together. We can say that if we add the two smaller, it's still going to be less than the two bigger ones added together. Okay, so those are things you can use. It's really reasoning, but you can just use it in a statement like, I am fine with this. 1 is greater than 0, 5 is greater than that, then you can add them together and they'll still greater. Okay, so that's what you can kind of use them as. You don't have to state the whole property in generic form. Okay, you can go through and just state what it is, how you would use it in that statement. Okay, so let's look at how we're going to use these, because that's the whole part. Okay, so here's one way we can use the last one. Let's say I have two triangles. Well, that doesn't look like it. Okay, just a minute. Okay, this is angle 1, this is angle 2. Okay.
This is 5.6.
Yeah, now this is 5.1 still. I'm showing how we use this. Okay, if I look at angle 1 plus angle 2 equals angle ABC. Do you agree with that statement?
Yes.
Okay. So we know that angle 1, from that I can say that angle 1 is less than, oh, this gets confusing with angles, doesn't it? Less than angle ABC. And we can also say angle 2 is less than angle ABC. Okay, that's all we can say there. But we do know that if these two are added together and they make this angle, then the parts, angle 1 and angle 2, have to be less than that. Very confusing when you're talking about angles, because I got all sorts of signs that look all the same. Okay, this is more short. This one actually, it's harder to see, but they're kind of hard to see. Okay, so let's just do a few of these. We're going to do a few on your paper right now in the book. Okay.
Not on the notes paper.
Sure, let's do this on your note paper. These are examples, because you can always refer to examples. These are examples of using this. Okay, how do we use this? Okay, so we're going to, okay, so what we're going to look at is, let me see. Let's start with 8, okay? It says, because pi, okay, it says pi divided by 7, no, pi is less than 22 sevenths. Okay, if that's true, then 7 pi is less than 22. This is problem number 8 on your paper. Okay. So what did I do there? Why could I say that's true? What did I do? This is where you have to think about, yeah.
You just multiplied both by 7.
Yeah, the reason why this is true is because we can multiply both sides by the same number and it will stay the same. Okay, that inequality doesn't change. Okay, so if I multiply both, so it is true because you can show you multiplied both sides by 7, so yes, it is true. That's using one of those properties.
Is it the division property?
It doesn't matter, it's actually the multiplication property, but I don't care about that. Okay, now, I did multiply by a negative. Remember, this number was greater than 7, so it still remained. Okay. So the next one is, if angle A plus B equals 90 degrees, so we know these two angles equal 90 degrees, then, here we go, angle B equals 90 degrees minus angle A. Okay, so if this is true, then this is true. How do I know? What did I do? Lucas, what did I do to get that statement? What did I do? Why is it true? It's good for you guys to realize what you're doing in each of these steps. What did I do to move that? So I got rid of the angle here, and I subtracted it here. So what did I do to both sides?
Subtracted them by A.
Yeah, I subtracted angle A from both sides. So the reason this is true is because I subtracted angle A from both sides. That's that subtraction property, but I don't care. Just tell me. You subtracted A from both sides. They stay the same because I subtracted the same number from both sides. Okay. Okay, so number 10. So this, I'm just showing you kind of how to write this. You don't have to put a lot of, here we multiplied by both sides by the same. Here I subtracted the same from both sides. So that's still true. Okay. The next one says if you have angle A is less than 90 minus A, angle A is less, okay. This is what we have. Angle A is less than 90 degrees minus angle A, okay? Then you can say that 2 times angle A is less than 90. 2 times angle A is less than 90 degrees, okay? What did I actually do on that problem to get that statement? Look at that carefully. How did I get from angle A is less than 90 degrees minus angle A to 2 of angle A is less than 90? Okay, yes.
You added angle A.
I did. I added angle A to both sides. I added angle A to both sides. So yes, that is true because I added the same thing on both sides of the inequality. So again, that's all you have to tell me there is why is it true. I don't care if you give me the actual inequality name or anything like that. I just want you to tell me because you added both sides, the same thing to both sides. Okay? And that's very true. Okay. The last one is if twice angle A is less than 90, so we're just really looking at this. Twice angle A is less than 90, then, okay, angle A is less than 45 degrees. So what did we do on both sides there to get to that, Paxton?
Divide by 2.
I divided by 2. Divided. Oh, that's funny. By 2 on both sides. It's really important to say on both sides, because otherwise, if I just divided by 2 on one side, they wouldn't be equal. So you have to say that I divided by 2 on both sides, okay? So that's just kind of using those to identify what you did. You're using the properties, but basically I just want you to explain why they're true, because I multiplied by the same number on both sides, because I divided. And actually you should say by a positive 2 and a positive 7 when you're talking about the multiplication and division, because the negative would not give you that same answer. Okay. So that's some examples of that. Now let's use it a little differently. Sounds about right? Okay. So let's see. Let's look at the deceiving appearances, which is 13 through 19 right now. So we have A, B, C. They're not going to be drawn at all like the picture because I just draw them, and D, E, F. So mine are not drawn to look congruent, but it says they look as if they're equilateral and congruent, but they are not. Okay, so they look like they're equilateral and they look like they're congruent, but they're not. It says if triangle ABC, so in this one, side AB is greater than AC. So AB is greater than AC. Even though it may not appear like it, AB is greater than AC. Okay? And it says AC equals BC. So it says AC equals, is it BC? BC, sorry. Okay, so that's what we're given there. I'm just reading what we're given. So what kind of triangle is angle or triangle ABC? What kind of triangle is it, Luke or Blake?
Isosceles.
An isosceles, because we have 2 sides. This one is equal to this, so it is isosceles. Okay, we can determine that based on that information. Okay. What can you conclude about AB and BC? What can you conclude about AB and AC? What do you know? Yes.
They're not congruent.
Well, let's look at AB. So 2 is, they want you to conclude something about AB related to BC. Not AB. That's not wrong, right? What was it? AB and BC. Oh, that is correct, isn't it? AB and BC, yes. So if you know that AB is greater than AC and AC is equal to BC, what can you determine?
Nathan Gillock, he's gonna be helping me getting, yes, let's.
So if AB is bigger than AC and AC is equal to BC, what does that tell me?
AB is greater than BC?
Correct. Okay, because look, AB is greater than AC. So if AC is the same as BC, then AB has to be greater than BC. So we can conclude that. Okay, these are things you might do when you're looking at stuff in problems. You might use inequalities because they may only tell you that one's bigger than the other. Okay, so the next one says, why? Well, you can say, if you want to say you substituted BC into there, that's fine, because that's what you really did. If AC and BC are the same, then you can replace AC with BC. That would basically be, so 3y, since AC equals BC, you can replace AC with BC. Does that make sense? Okay. Since they're equal, I can interchange BC and AC. I can use them as the same thing. Okay, the next one, in triangle DEF. Now we're on the other triangle. DF is greater than EF. So DF is greater than D. Wait, did I just do that wrong? No, that's right, EF. And EF is greater than DE. Okay. 16, if that's true, what kind of triangle? 16, how did I get, oh, how did I label these wrong? This was 13. 14, 15, okay, 16. If that's true, what can I say about that triangle? What kind of triangle is it? Yes,
Scaling,
it's scale, that's, yes, scalene, thank you. I had to think about that a moment. Scalene, why? This is not asked, but why? What do you know? If DF is greater than EF and EF is greater than DE,
None of them are.
none are the same, so it has to be scalene, okay? Okay, so then, what can you conclude about DF and DE? Well, let's look at it. We want to conclude something about this. Well, if DF is greater than EF and EF is greater than DE, then what do I know about DF and DE? So if it's,
DE is less than DF.
Yeah, it is.
yes, DE is less than or DF is greater than, okay? Because these are basically gonna, that's gonna be in between, because we know DF is greater than this is greater than that, so EF is actually in the middle of those. Okay, so DF has to be greater than DE. Okay, why? You could actually draw it out if you wanted to. DF, greater than EF, but EF is greater than DE. So that tells me this one is greater than that one. Okay, because EF is in between. So that'd be a way of showing why for 18. 19, why aren't the triangles congruent?
one's scaling and one's isosceles.
Correct, that's a good answer. One's scalene, one's isosceles. Okay, so that is definitely a good reason. So again, you're just talking, they're getting you to think about what all these things mean. So remember, how to read your signs and what that actually means when you're looking at it. So this, it takes a little bit of practice getting used to inequalities. Equal signs we're used to, But inequalities we don't use as much, but actually in the real world, we do use inequalities quite a bit because things are not usually equal. And we do use that one thing is bigger than the other, and then we can make adjustments for that. So go ahead and take a 10-minute break. You need it.